A very good day to you, ladies and gentlemen, and thanks for having come to this web meeting. Over the next half an hour, we are going to take you through Go Live with XIV. IBM has been having very exciting storage products, and this is one of the most latest addition into the IBM stable. I have been in the storage business for the last 10 years, and I have seen Indian market wherein in the year 2000 there were very few customers who were talking about a terabyte of storage, and we as sales guys were getting excited by seeing those customers. And today, 2010, there are customers who are talking about petabytes of storage. In fact, there are customers who are adding about a terabyte of storage on a daily basis. This is the situation that is there in the Indian market today. I would like to call upon Kumar Nagaraj, who is our consultant in storage, to give you a little bit of background about Kumar. Kumar was with EMZ. He heard about XIV. He was very excited, and he decided to join IBM to support the XIV cause. So I would like to call upon Kumar to take you through this exciting product of IBM technology. Thanks a lot.
Thank you, Atul, and thank you very much for taking time off and basically coming and spending some time with us to go into this event, Go Live with XIV. My name is Kumar Nagaraj. I work for IBM STG. I'll take you through the architecture presentation for the next few minutes, followed by a demo of XIV to demonstrate how easy it is and from a management perspective and what are the differences from traditional architecture. I just want to start off with a current industry, where the storage industry is and what are the challenges we face in the current market. If you look at the industry today, you have different kinds of drives. The storage administrator / CTO, CIO's office needs to make a decision of what kind of drives they need to buy and how to manage what applications to put on what storage, what drives. And also, a lot of storage technologies like RAID groups and how to manage the RAID groups. Over and above this, based on the last few years, the green initiatives, power is a challenge, infrastructure in terms of space and utilization in data centers. Either, companies have the data centers already full and they are kind of looking at, minimizing the space and utilizing the existing space to do more. So the good thing about what XIV we did was to kind of start the design process of designing a storage 10 years after the industry was already in. And that gave us an opportunity to address some of these challenges and make sure that we can kind of help the organization to do more with less, both from a cost perspective and an infrastructure perspective. So if you look at what the design principle or the goal for designing a new storage device was to kind of make sure reduce the complexity. And complexity, I mean, in terms of management, in terms of implementation, in terms of designing the solution, deploying storage and data on your storage devices. As we go further, you'll see how we have made this as our goal to do this. I'll start off again by kind of looking at what is the architecture in the existing traditional architecture, where you have a proprietary backplane design, you have a bunch of drives on the back end which are connected to fiber channel loops. You have you calculate hot space, you need to figure out what is the cache required based on your applications and what is your performance requirement. This actually is not it's a challenge across the industry. It doesn't matter if you're talking enterprise storage, you're talking mid-range. It's just the number of controllers and the amount of cache is what is the difference. But the actual challenge you see is in terms of the utilization. The disks can be utilized more or less, and you really have no control over it because the applications are deployed based on the performance requirements. And there's limited parallelism. Upgradability is a challenge. Moving data around is also a challenge. While we have got tools and skill sets to do this better over the last 4 or 5 years, still it costs money and it needs expertise to do that. If you look at what we did from XIV perspective is to take away the proprietariness of the box in the traditional architecture and make it a very standard component. Use all standard components. So we use Intel-based servers interconnect is a standard Ethernet at this point of time, and obviously we are going to change that at some point. And from a performance perspective, what we have done is gone from a centralized cache CPU architecture to go into a distributed grid-based architecture. Now, what this brings to the table is, you can grow as you need, your scalability is more, and you can also distribute the data based on, your performance requirements. And these are definitely, using new technologies. We have used commodity hardware, but put in software on top of it, which basically makes this, the enterprise class storage going forward. Just to give you a quick understanding of how mid-range and what we do in terms of implementation is, if you have two controllers, from a topology perspective, you have to distribute it and make sure that the controllers are evenly used and the packets flow based on how the runs are assigned to your service. If you look at an XIV kind of architecture, we use a massive parallelism and granularity to drive the performance using low-cost drives and standard CPUs. And you'll see that in a minute of how the data flows across and make sure that there is no single point of failure nor a single path for any kind of data. And obviously, when you're distributing and the granularity, you're utilizing all the components available for you, and there are basically no hotspots, and performance tuning is absolutely not required in this kind of a storage. Just to put on the same sheet of how XIV is different from traditional architecture, it's controller centric versus this is a grid and a scalable model. Centralized and shared cache kind of architecture. This is distributed, and again, it's not shared, but it's basically utilized in a very effective way. It's also, how do you scale beyond the controller? If you have two controllers, 4, 6, 8, how do you make sure that that's not a bottleneck for you from a performance perspective? We can scale in different dimensions, scale out and scale up, kind of an opportunity. So if I had to put on, what are all the benefits of XIV, and this would be the chart where, it's an enterprise class storage, multiple level of redundancy, self-healing, no tuning required, ease of use. I mean, we will look at a few of these things during our demonstration afterwards, and as well as the few charts. But if you look at what we have done, a few things differently is the box is always measured in usable capacity. Or if we say that 27 terabytes or 80 terabytes, it's all usable capacity. It is not raw, and then you don't have the overhead of calculating what is the usable you get out of it. It also has some unique features of some of the challenges you have in the industry from a RAID group perspective. A 1 terabyte drive, the data on a 1 terabyte drive can be rebuilt in 30 minutes. And I think that's something which is very unique for the box. And also deployment of a box and designing for future needs is pretty much gone from a storage administrator perspective. It is basically roll the box into the data center, and in less than 4 hours the box is ready for provisioning storage to your host. From a hardware perspective, just want to give you a quick summary. It's a full rack. It comes in a rack all the time. It has Intel quad-core processors, 8 GB of memory in each module, 12 terabytes in each module. It has 4 GB 24 ports SCSI fiber channel and 6 iSCSI ports in the box today. So fiber channel and iSCSI is native in the box. It's not an add-on kind of a thing. The starting point is a 6-module box, and one full rack will consist of 15 modules, which will give a usable 80 or 160 terabytes today. I think that's kind of probably the most compact storage in the industry today. Anything in upwards of 80 will require 2 frames in traditional architecture. We fit all of it into a 1 frame, and it's extremely compact from a form of compactor perspective. All data is always mirrored. There are 2 copies of data in the system always. And from a 6 rack to 15 rack, 15 modules, you can grow in increments of 5 or 15 terabytes depending on what's the requirement.